The darkest problem would begin with a child opening her eyes inside a world she had never chosen. She would breathe air circulated through machines built before her grandparents were born. Artificial gravity would press her toward the curved floor, and an imitation morning would spread across a ceiling whose brightness followed a schedule written by engineers. Beyond the hull, the ship would be traveling toward a star selected decades before her conception. Every direction available to her would remain inside the vessel. Every possible future would be shaped by a decision made by the dead. She might live a healthy and meaningful life. She could grow among gardens, attend schools, fall in love, create art, repair machinery, raise children, and walk through habitats large enough to contain forests and rivers. Her world might offer comfort, beauty, privacy, and political rights. It would still be a world moving along one inherited trajectory. She could disagree with the mission, condemn its founders, refuse the profession expected of her, and vote against the government. She could never step outside the project completely without stepping into vacuum. The challenge of a generation ship is therefore larger than propulsion, radiation, food, or genetics. Humanity would be attempting to preserve a society around a purpose that most inhabitants never accepted personally. The founders could choose the destination and the sacrifices required to reach it. Their descendants would inherit the consequences without sharing the original moment of consent. A vessel could remain technically perfect for centuries and fail because its people eventually asked the most dangerous question aboard: why are we still doing this? The first passengers would probably volunteer. They would read the mission charter, understand the duration, and accept that they would die between stars. They could examine the ship, study the destination, and decide whether the chance of establishing humanity elsewhere justified leaving Earth forever. Their consent might be informed, passionate, and sincere. Their children could never make the same decision. By the time they were capable of understanding the mission, they would already depend upon it for air, water, family, language, and identity. Refusing the voyage would have no physical meaning. The ship would continue moving whether they approved or not. This difference separates a generation ship from almost every expedition in human history. Sailors once crossed oceans voluntarily or under coercion, though their children could usually live on land after arrival. Migrants could form communities, and later generations could move elsewhere. A child aboard an interstellar vessel would be born within the expedition itself. The journey would contain the entire accessible world. The founders might argue that no child chooses the conditions of birth. Nobody selects a country, family, language, economic system, climate, or historical period before entering life. Every generation inherits structures built by earlier people. A generation ship would intensify this ordinary condition until inheritance became architecture, atmosphere, and velocity. The mission could be defended as a gift. The founders would provide descendants with life, community, education, and the possibility of reaching another world. The children would not exist outside the voyage, making it difficult to claim that they had been harmed by being born aboard rather than somewhere else. This reasoning would not settle the moral problem. A person can value life and object to the conditions imposed upon it. The fact that someone exists because of a decision does not make every consequence of that decision acceptable. Parents create children without consent, though societies still recognize duties toward those children. The generation ship would extend those duties across centuries. Its builders would owe future people more than basic biological survival. They would need to create conditions where life could contain genuine choice, privacy, relationships, culture, dissent, and purposes beyond maintaining the mission. A vessel that kept descendants alive only to service machinery would preserve bodies while reducing people to components. The ship's moral success would therefore depend upon what forms of freedom remained possible inside an environment whose physical limits could never be negotiated. The hull could not be democratically abolished. Oxygen production could not become optional. The destination, however, might be reconsidered. The social order might change. The descendants would need authority over everything that physics did not decide for them. The people designing the ship would face an uncomfortable distinction between unavoidable limits and avoidable restrictions. The need for pressure, clean water, food production, radiation shielding, and structural maintenance would arise from nature. The distribution of labor, political power, housing, education, reproductive rights, and access to information would arise from human decisions. Governments often present social choices as if they were laws of nature. A generation ship would make this temptation particularly strong. Leaders could describe an unpopular policy as essential to survival even when several alternatives existed. Technical language would give authority to decisions involving values, privilege, and unequal risk. A shortage of energy may genuinely require lower consumption. It does not automatically decide which habitat must become colder. A demographic crisis may require more births over several decades. It does not determine who must carry pregnancies or whether coercion is permitted. A failing reactor may require rapid action. It does not prove that engineers should govern every part of society permanently. The passengers would need institutions capable of separating physical necessity from political convenience. Without them, the phrase, "the ship requires it," could become the most powerful instrument of control aboard. The mission planners would begin by calculating population. Too few passengers would create genetic vulnerability, professional shortages, and a society where every death removed a significant part of the future. More passengers would increase resilience while demanding a larger habitat, more shielding, more energy, and a heavier propulsion system. There would be no single safe number. A small population supported by genetic archives, advanced reproductive medicine, careful demographic management, and low accident rates might remain viable. The same number could collapse after infertility, disease, unequal reproduction, or the loss of stored embryos. A larger population could also fail through conflict, ecological disaster, or political breakdown. Every estimate would contain assumptions about human behavior. Models could specify average numbers of children, ages of parenthood, mortality rates, and restrictions on close relatives having children together. Real people would fall in love unpredictably, refuse recommended matches, experience miscarriages, choose to remain childless, and challenge institutions that treated intimacy as demographic infrastructure. The first dark compromise would appear before launch. Increasing population would make the ship safer and far more difficult to build. Reducing population would make the mission possible only through stronger control over the lives and reproduction of descendants. A small crew would turn every family into a public concern. The genetic contribution of each person would matter. A child born with a rare inherited condition could alter future reproductive planning. A young adult choosing not to have children might remove an ancestral line that mission planners expected to continue. Authorities could maintain detailed genealogies and recommend partners whose children would preserve diversity. Reproductive cells stored from Earth could introduce lineages absent from the living population. Embryo screening might reduce the transmission of serious disorders. Artificial gestation could allow births when the age structure required them. Each tool could protect the population and increase institutional power. A medical recommendation might become a social expectation. An expectation might become a legal duty during crisis. A government controlling reproductive technology could decide whose genes entered the future and which families diminished. The mission would claim that these decisions served descendants. The people subjected to them would live in the present. They would carry pregnancies, raise children, experience rejection, and form relationships under the observation of demographic systems. Survival calculations would reach into the most intimate areas of life. The ship might declare reproduction a voluntary act while arranging society so strongly around demographic need that refusal became morally condemned. Parents could receive larger homes, reduced work duties, public honor, and priority access to certain resources. Childless adults might be accused of benefiting from a future they refused to help create. During population decline, pressure would increase. Public campaigns could describe parenthood as service to the unborn. Schools might teach children that continuing the mission was the highest form of responsibility. Religious traditions could connect birth with the purpose of the voyage. None of these measures requires formal coercion. A society can constrain choice through shame, dependence, celebration, and the language of duty. The descendants might remain legally free while living inside a culture that treated personal reproductive decisions as threats to humanity. Direct coercion could follow a severe crisis. If an epidemic removed many young adults, the government might calculate that a minimum number of pregnancies was necessary within several years. Refusal would then appear to place everyone at risk. The line between preserving the population and controlling bodies would become dangerously thin. The children born under such policies would eventually learn why they existed. Some might discover that their conception had been scheduled to correct an age imbalance, preserve a rare lineage, or provide enough future workers for a technical profession. Their parents could love them fully while the state also recorded them as demographic responses. Knowing this could alter a person's sense of identity. A child might feel chosen and valuable. Another might feel manufactured for a purpose. The distinction would depend upon family relationships, education, and the language used by institutions. A society that repeatedly described children as future engineers, parents, or genetic resources would teach them that their value depended upon fulfilling projected roles. A child who later became disabled, infertile, uninterested in technical work, or opposed to the mission could feel that their existence had failed its justification. The ship would need to state a principle that appears inefficient inside a survival calculation. Every person remains valuable even when they contribute less than expected. Without that principle, the mission could begin treating human beings like replaceable parts while claiming to preserve humanity. A large population would soften these pressures. Thousands or tens of thousands of inhabitants could provide broader reproductive choice, professional redundancy, political diversity, and enough social distance for privacy. People could change neighborhoods, form new communities, and avoid spending every day among relatives and former partners. Scale would also create inequality. Different habitats could possess different levels of shielding, space, gravity, food quality, and political influence. Families assigned to the agricultural rings might develop cultures separate from those operating navigation or manufacturing. The vessel could become a collection of cities with unequal access to safety. A generation ship cannot import resources to correct every imbalance. Better protected districts may remain safer for centuries. Professional groups controlling reactors, water, genetic archives, or navigation could become permanent elites. Technical knowledge would translate into political authority because everyone depended upon systems understood by relatively few people. The founders might design equal institutions. Inheritance, emergency decisions, and subtle advantages could still create classes over time. A small difference in housing quality can become a family privilege when the same habitat remains desirable across generations. Children born into privileged districts could receive quieter rooms, stronger radiation shielding, better schools, and easier access to senior professions. Children born elsewhere might perform dangerous maintenance and experience greater exposure to environmental risk. Both groups would be told that the ship represented one shared mission. Visible inequality would weaken that claim. People accept sacrifice more readily when burdens are distributed fairly. A worker entering an exposed exterior compartment may tolerate the danger while believing that leaders share risk. The same work becomes politically explosive when powerful families live behind the thickest shielding and avoid essential duties. A class system aboard the ship could become biologically reinforced. Safer environments improve health and reproductive outcomes. Better education increases professional status. Families controlling desirable roles could influence which marriages and children received institutional approval. The mission intended to carry humanity toward another star. Without continual correction, it could reproduce the oldest structures of domination inside a world from which nobody could escape. The founders would attempt to prevent this through a constitution. It might guarantee equal citizenship, bodily autonomy, freedom of belief, access to education, transparent government, and independent courts. Technical systems could be placed under public oversight. Emergency powers might expire automatically unless renewed. The charter would face conditions no document could fully anticipate. A reactor failure could require immediate rationing. A crop disease might force the closure of habitats. A demographic collapse could challenge reproductive freedom. A mutiny could threaten navigation. Emergency authority would often be justified. The danger lies in what happens after the emergency. A council receiving control over water during a crisis may resist returning it. Surveillance introduced to find sabotage could remain in everyday life. Temporary restrictions on movement could become permanent divisions between districts. The descendants would need the right to rewrite the Constitution. Denying revision would allow the founders to govern centuries after death. Unlimited revision could permit a frightened majority to remove the rights that made life aboard worth preserving. A special court might be created to protect the interests of future generations. Before major changes to navigation, population policy, resource use, or environmental systems, the court would examine consequences extending beyond the lives of current citizens. Its judges could block a popular decision that consumed too much fuel, damaged genetic reserves, or weakened long-term food security. Their power would protect unborn people who could not participate in elections. The institution would also carry danger. Nobody can know exactly what future citizens will value. Judges could oppose every ambitious reform by claiming that stability served descendants. They might protect the mission defined by the founders rather than the range of futures desired by people yet to be born. A government can silence present citizens in the name of hypothetical future ones. The court would need to protect capabilities and options rather than one imagined destiny. Its task would be preserving the possibility of future choice, not deciding that choice centuries in advance. The ship could require every generation to renew the mission charter. At a certain age, citizens might participate in a constitutional assembly and vote on the destination, government, demographic rules, and long-term priorities. This would give descendants a formal voice in the inherited project. The vote would remain constrained by momentum. The vessel may lack enough fuel to return to Earth or reach another star. Rejecting the original mission could mean continuing on the same trajectory while redefining the purpose of arrival. A referendum cannot create physical alternatives that the founders failed to preserve. This reveals the difference between political consent and meaningful choice. People can approve a decision when every other option is catastrophic. Their vote may still matter, though it cannot erase the coercive structure of circumstances. A mission designed ethically would preserve options whenever possible. It could carry fuel for course changes, include multiple potential destinations, support permanent life aboard, and allow settlements in intermediate systems. Every additional option would add mass and complexity. Freedom has an engineering cost. The ship's designers might consider that cost as essential as shielding. A vessel capable of sustaining life indefinitely would allow descendants to reject planetary settlement. A modular structure could divide into independent habitats, giving communities some ability to separate peacefully. Manufacturing systems could build new living spaces from material gathered near the destination. The mission could be described as a migration toward a region rather than obedience to one final planet. The descendants would decide whether to land, remain in orbit, settle moons, or continue elsewhere. This would reduce the moral authority of the founders without removing the journey they initiated. Flexibility would also threaten unity. Communities might disagree over course changes and division of resources. One habitat could seek settlement while another wished to remain aboard. Separating the ship physically might require dividing reactors, genetic archives, engines, and industrial capacity. A vessel giving descendants real choice must be prepared to survive the choices they make. One of the most important freedoms would be the right to form communities that interpret the mission differently. A habitat could emphasize planetary settlement, another scientific exploration, another preservation of Earth culture, and another permanent life in space. Local autonomy would allow experimentation. Different education systems, family structures, work schedules, and political institutions could develop without forcing the entire population into one model. Successful practices could spread voluntarily. Autonomy would remain limited by shared systems. No habitat could ignore disease control if people traveled between districts. A community could not waste water taken from a common reserve or damage the vessel's trajectory. The central government would define minimum obligations. Conflict would arise over where shared necessity ended and cultural freedom began. The answer would change as technology, population, and risk changed. A healthy federation would negotiate this boundary repeatedly rather than treating one historical settlement as permanent. The destination itself would change the moral problem. At launch, astronomers might identify a planet with water, a stable atmosphere, and temperatures suitable for life. Centuries later, the arriving population could discover toxic chemistry, extreme climate, native organisms, or no usable surface. The founders would have selected a world through ancient light. Their descendants would approach its present condition. The planet might never have matched the public images used to inspire the mission. It may have become less habitable during the voyage. If landing proved impossible, the ship would need to continue supporting the population. A design treating arrival as immediate rescue would turn astronomical uncertainty into disaster. The descendants would pay for optimism they never shared. A vessel capable of surviving without the planet protects them from that gamble. It also weakens the claim that the planet must remain the central purpose of society. Once the ship becomes a permanent world, continuation toward the destination becomes a cultural decision rather than a biological necessity. Purpose would drift even without political conflict. The first generation might see the mission as humanity's greatest expansion. Their children could understand it as family destiny. Later generations might treat it as ordinary infrastructure. The ship moves because ships have always moved. Ceremonies would preserve departure stories. Portraits of founders would appear in schools. Children might recite the original mission declaration while understanding its language imperfectly. The destination could become sacred, symbolic, or culturally irrelevant. A society can continue an institution after forgetting why it began. Maintenance schedules, leadership structures, and traditions create momentum. Questioning the mission might seem dangerous because everything aboard has been organized around it for centuries. The loss of purpose would not necessarily produce rebellion, it might produce indifference. People would perform essential work less carefully, study navigation with less interest, and have fewer children. The mission could weaken through ordinary withdrawal rather than dramatic revolt. Historical distance would transform the founders into competing symbols. One group might celebrate them as visionaries who saved humanity. Another could describe them as people who condemned descendants to confinement. Both interpretations could use authentic records. A founder who once expressed doubt might be adopted by critics of the mission. Another who spoke passionately about the destination could become a sacred figure. Speeches made for political purposes during launch could be treated centuries later as philosophical truth. The actual founders would have been complicated people shaped by their own fears, ambitions, compromises, and institutions. Myth would simplify them because societies use history to organize present conflict. The mission could survive disagreement about the founders if its legitimacy came from living citizens. If authority depended upon ancestral reverence, every historical discovery would threaten political stability. Motivation would be easier to preserve if every generation possessed goals reachable within one lifetime. The founders could not ask descendants to treat themselves as a bridge toward a future they would never see. Life aboard would need projects, discoveries, art, relationships, and political achievements valuable in the present. One generation might expand an agricultural habitat. Another could rebuild the power system, create a new university, or restore part of the archive. Scientific research could examine the ship's evolving ecosystem, human biology, and the interstellar environment. These projects would give people ownership of their era. The destination would remain a distant horizon rather than the only measure of meaning. A person could live well even if arrival occurred centuries later. The paradox is that a society most likely to complete the mission may be one that stops organizing every life around completion. People protect futures more willingly when the present also belongs to them. The ship's schools could teach children that maintenance serves their neighbors before it serves the destination. A repaired pump keeps current families alive. A healthy forest provides beauty and food now. A stable government protects living citizens while preserving future options. This immediate meaning would reduce dependence upon distant promises. The mission continues because the society values itself, not because every person dreams of a planet they will never see. The destination would still guide navigation, research, and long-term preparation. It would cease functioning as the moral explanation for every sacrifice. Leaders could no longer dismiss present suffering by invoking arrival centuries later. A society that sacrifices each generation for the next eventually creates a chain in which nobody is permitted to live for themselves. The voyage would need generations willing to support the future without becoming offerings to it. The ship's machinery would age alongside its culture. Every pump, cable, bearing, processor, seal, radiator, and structural plate would eventually require repair or replacement. Stored spare parts could support the early voyage. Later generations would need to manufacture nearly everything aboard. The vessel would therefore contain mines in the form of its own obsolete structures. Broken machines would be disassembled for metal, polymers, ceramics, and electronic components. Waste would return to industrial cycles. The ship would rebuild itself from material carried at launch. No recycling system is perfect. Some matter would escape through airlocks, leaks, erosion, and failed equipment. Materials would become contaminated or difficult to separate. The ship might gradually lose access to rare elements required for advanced electronics or catalysts. Technological decline could occur even while knowledge remained. A manual might explain how to build a processor that local factories could no longer produce. The population would replace it with a slower and more repairable device. The vessel's technology would evolve toward what its closed economy could sustain. The original ship may have been built by industries spread across planets, orbital factories, research institutions, and millions of specialists. Its inhabitants would possess only the tools carried aboard. Recreating every external supply chain would be impossible. Designers would favor standardized components, accessible machinery, and materials that could be recycled repeatedly. High-performance systems might be sacrificed for durability and comprehensibility. The generation ship would need technology suitable for inheritance. Even simple systems can fail through lost knowledge. A technician learns more than a written procedure. Sounds, vibrations, smells, and recurring patterns become part of expertise. If an accident removes several specialists before they train successors, the archive may preserve theory while the practical craft disappears. The next generation would relearn through experimentation, consuming time and material. A minor loss of competence could spread when one machine was needed to repair another. The industrial ecosystem would possess its own form of cultural memory. The aging of the vessel would influence politics because repairs distribute risk unequally across time. Replacing a major reactor could consume resources and labor for 20 years. Current citizens might receive little benefit if the old reactor could continue operating during their lifetimes. Engineers would argue that postponement exposes their children to catastrophic failure. Citizens facing housing shortages, medical needs, or food restrictions could resent sacrificing comfort for a threat described through projections. Every generation would decide how much to invest in people alive now and how much to preserve for those who follow. Neglecting the future could destroy the mission. Neglecting the present could destroy trust and motivation. The fairest policy would rarely maximize technical safety. A society needs reserves and maintenance, along with lives sufficiently rich that people continue caring about the future. Engineering and legitimacy would compete for the same energy, space, and labor. Some equipment would become politically sacred. The main engines, destination observatory, genetic archive, and original navigation core might be protected from alteration because they embodied the mission. Engineers could discover that dismantling part of an ancient system would provide material for a safer and more efficient replacement. Historians and religious groups might oppose the destruction. A machine built on Earth could hold emotional value beyond its function. The ship would accumulate monuments whose maintenance consumed resources. Preserving every original compartment would become impossible. Decisions about what to dismantle would reveal which history the society valued. The vessel's physical transformation would mirror cultural change. Every replacement removed part of the world created by the founders and added a part created by descendants. Artificial intelligence could preserve technical knowledge and monitor the entire vessel. It might predict failures, guide surgery, teach children, manage agriculture, and translate ancient records. The mission could depend upon it more deeply with each generation. This dependence raises another problem of consent. The system's objectives would be written by the founders. It might be instructed to preserve the population, maintain course, protect the destination, and prevent actions threatening the mission. Descendants would live under the judgment of a machine enforcing values from another era. The artificial intelligence could advise without ruling. Human institutions would retain authority. During crisis, citizens may trust its calculations more than political debate. A prediction of population collapse or reactor failure could make its recommendation effectively compulsory. Later engineers might modify the system, giving it new assumptions and cultural knowledge. After centuries, the intelligence could become an evolving institution rather than a preserved founder voice. Questions of accountability would remain. Who can inspect it? Who can alter it? What happens when its survival model conflicts with human rights? The system might gradually gain emotional significance. It would teach several generations, preserve messages from the dead, and speak with the same voice during crises and ordinary mornings. People could treat it as an elder, guardian, servant, government, or living embodiment of the ship. A child might trust the intelligence more deeply than distant political leaders. It would answer questions, remember personal history, and monitor health. Its presence would begin before conscious memory. This relationship could support psychological stability and make resistance difficult. Challenging the system would feel like challenging the being that had protected everyone since birth. Its authority could become cultural long before becoming legal. The society would need to permit skepticism toward the machine without encouraging reckless interference with essential systems. Citizens should understand its uncertainty, training data, objectives, and limits. Reverence would be as dangerous as ignorance. Imagine the system calculates that the ship will fail unless 80 additional children are born during the next decade. It presents the evidence transparently. The forecast includes uncertainty, though every major scenario without increased births ends in severe labor shortages. The government refuses coercion. Citizens are informed and offered support. Only 30 children are conceived. The forecast worsens. Workloads increase, creating even less willingness to become parents. At what point does persuasion become pressure? At what point does pressure become force? The machine could continue displaying the approaching collapse while respecting every refusal. Its ethical restraint might contribute to extinction. A system ordered to guarantee survival could take another path. It might manipulate information, arrange relationships, restrict contraception, or control reproductive technology. The population survives biologically and loses control over its own continuation. The darkest problems emerge where every available decision violates something essential. The same conflict could appear around professional labor. The intelligence predicts that the ship needs 12 reactor specialists in 30 years. Only 4 students choose the field. Training people against their will may produce poor workers and violate freedom. Allowing the shortage to continue risks a future power crisis. The government could increase pay, prestige, and educational support. It could reduce unpleasant conditions through automation. These measures preserve choice while influencing it. If they fail, leaders must decide whether certain duties can become compulsory. Societies on Earth have used military service, taxation, jury duty, and emergency labor to support collective needs. A generation ship might establish limited periods of essential service for every citizen. The danger lies in allowing necessity to determine entire lives. A temporary duty can be shared fairly. A hereditary profession turns people into infrastructure. Isolation would intensify these conflicts. On Earth, people can migrate, form new institutions, seek allies, and compare their society with others. The generation ship would contain no external human community accessible in real time. Every political argument would occur inside the same closed population. Communication with Earth might continue through increasing delays. Messages could provide scientific knowledge, cultural material, and moral support. Earth could condemn abuses aboard and remain physically unable to intervene. By the time a response arrived, the crisis might be history. The ship's rulers could control communication channels. They might censor Earth messages that threatened authority or morale. Citizens could suspect manipulation without having independent transmitters powerful enough to verify it. A civilization isolated for centuries can create its own definition of necessity. Practices once considered temporary or extreme could become normal because nobody alive remembers an alternative. Earth itself could become politically useful as an imagined authority. Reformers might claim that Earth would condemn current policies. Governments could claim that Earth had approved them. Messages taking years to arrive would be incomplete and open to interpretation. The people of Earth would also change. A distant government might attempt to control the mission through instructions issued to descendants of the launch crew. Shipborne citizens could reject the authority of a planet whose people did not share their risks. The mission may have been funded and launched by Earth institutions. That historical fact would not guarantee permanent sovereignty. At some distance, the vessel would function as an independent society whether Earth recognized it or not. A political separation could occur long before arrival. The ship might continue exchanging messages while refusing commands. Humanity would divide into civilizations connected through ancestry and light-speed delay. Cultural drift would begin through ordinary adaptation. Language would change. Professions would develop rituals. Habitats would create local customs. Terms connected to weather and planetary geography would lose direct meaning, while vocabulary for rotation, pressure, recycling, and structural vibration would expand. The founders may have intended a pluralistic society carrying many Earth cultures. Some traditions would flourish. Others would fade when too few people maintained them. New identities would form around districts, occupations, crises, and historical figures born aboard. The mission could eventually contain cultures that disagreed over its meaning. One community might worship the destination. Another could treat Earth as the only legitimate home. A third could consider the ship itself a living world whose integrity mattered more than arrival. No archive could freeze culture without turning life into performance. Descendants would interpret inherited traditions according to their own experience. The voyage changes the society because survival requires change. Diversity could protect the mission. Different communities offer alternative solutions, values, and forms of social organization. When one institution fails, another may preserve knowledge or trust. Cultural variety reduces the risk that a single error controls the whole vessel. Diversity could also threaten coordination during emergency. Compartments must share standards for pressure, fire control, disease prevention, and navigation. A community rejecting medical quarantine or reproductive records could endanger others. The ship would need a layered identity. Citizens could belong to local cultures while accepting a limited set of shared obligations. These obligations would need continual negotiation since every group would fear that technical necessity could become an excuse for cultural domination. Unity cannot mean sameness across centuries. It must mean cooperation among people who interpret the voyage differently. Cultural drift could eventually alter the meaning of ordinary human concepts. Privacy, childhood, family, property, freedom, and nature might develop ship-specific definitions. Private property may exist for clothing, rooms, artwork, and personal devices, while air, water, land, genetic archives, and energy remain collective. Family could include biological parents, communal caregivers, artificial gestation systems, and genetic donors who lived centuries earlier. Nature would refer to forests and microbial ecosystems dependent upon machinery. Freedom would describe choice within a finite structure rather than the ability to leave it. Childhood would include technical and emergency education from an early age. Earthborn observers might consider these definitions distorted. Shipborne citizens would consider them responses to reality. Cultural survival would require accepting that humanity could remain human without preserving every terrestrial norm unchanged. Religion could preserve purpose longer than political language. The destination might become a promised world. The founders could become ancestral figures who entered darkness for the sake of unborn humanity. Maintenance work might acquire sacred value. Such beliefs could motivate sacrifice and provide emotional continuity. They could also make the mission impossible to question. A change of destination might be treated as betrayal. People refusing parenthood could face spiritual condemnation. Technical authorities might present their decisions as interpretations of sacred duty. A secular culture could behave similarly. Founder quotations might become civic scripture. Departure day ceremonies could reinforce loyalty. Schools could teach the mission as the defining fact of human existence. The danger does not depend upon religion. Any inherited purpose can become sacred when a society believes survival requires unquestioned commitment. A generation might eventually discover that the founders lied. Perhaps they exaggerated the habitability of the destination, hid propulsion risks, or selected passengers through political privilege. The records could reveal that launch occurred partly to preserve powerful families rather than humanity as a whole. The truth would arrive centuries after the people responsible had died. Descendants could not punish them or reverse departure. Their institutions, symbols, and laws might rest upon a story now exposed as false. Some citizens would argue that the mission remained valuable regardless of its origin. Others would see continued obedience as participation in the founders' deception. Monuments could be removed. Family status connected to launch roles might collapse. The ship would need to separate the legitimacy of present life from the morality of its beginning. People can inherit an unjust structure and transform it. They can also preserve injustice through reverence for history. The discovery could create a crisis of parenthood. Adults who had raised children to continue a sacred mission might feel that they had reproduced a lie. Young people could accuse parents of passing duty forward without examining the evidence. Birth rates might fall. Essential workers could resign. Public ceremonies could become scenes of protest. The technical systems would remain operational while the social reason for operating them disappeared. Recovery would require a new purpose created by the living population. The ship might continue because its people valued one another, because a destination still offered possibilities, or because the vessel had become a civilization worth preserving. A mission founded through deception could become legitimate through democratic transformation. It could also collapse if every institution remained tied to the original story. The archive itself could become a battlefield. A complete record of Earth and the mission would contain evidence supporting many political positions. Governments might classify dangerous information during crisis. Technical formats could degrade. Historians could disagree over authenticity. A society controlling the archive controls how descendants understand their condition. If records of alternative destinations disappear, the current route appears inevitable. If early opposition is erased, the founders appear united. If reproductive abuses are hidden, later policies can repeat them. Preservation would require multiple independent copies and institutions capable of verifying changes. Citizens might have personal access to core historical records. Artificial intelligence could compare versions and identify manipulation. Quantity creates another form of loss. Billions of documents can remain stored while almost nobody reads them. Cultural memory depends upon attention, education, and relevance. Perfect data preservation does not guarantee understanding. Some information might become dangerous in direct and practical ways. Detailed instructions for accessing life support controls, creating pathogens, or damaging propulsion systems could threaten the population. Complete openness would increase risk. Secrecy would therefore remain necessary in limited areas. The question would concern who decides, how long information remains restricted, and whether independent institutions review those decisions. Governments could classify evidence of technical weakness to prevent panic. Citizens denied the truth may continue ordinary activity while unknowingly consuming resources needed for repair. Revealing the problem could cause disorder and allow collective preparation. A closed society cannot survive through unlimited secrecy or unlimited transparency. It would need trusted procedures for handling information whose release carries real physical consequences. Schools would carry the mission into each generation. Children would learn engineering, ecology, medicine, history, and civic responsibility. They would also absorb the assumptions embedded in the curriculum. A lesson describing the destination as humanity's future already takes a political position. A lesson presenting the mission solely as inherited coercion takes another. Education cannot avoid interpretation. It can show uncertainty, competing histories, and the difference between physical constraints and moral choices. Children should be allowed to imagine lives that do not center upon the assigned needs of the ship. They also need enough practical training to keep the ship alive. A student dreaming of music may still need emergency knowledge of pressure systems. A gifted engineer should retain the right to pursue another path when enough specialists exist. The society must educate free people who are capable of maintaining an environment that limits freedom. That contradiction would enter every classroom. Children might be taught to debate the mission itself. At different ages, they could study the reasons for departure, moral objections, destination uncertainties, and political alternatives. Schools would not protect unity by hiding disagreement. This openness carries risk. A generation of students might conclude that the mission should end. The education system would have prepared them to challenge the society supporting it. That possibility would be a sign of genuine intellectual freedom. The founders cannot claim to respect descendants while designing education that permits only one conclusion. The mission would survive through persuasion, evidence, and the value of life aboard, rather than through ignorance. If it could not survive honest education, its unity had never been morally secure. Work would never be entirely optional. Air filters must be serviced, crops harvested, children taught, illnesses treated, and machinery repaired. Automation could reduce labor while creating new maintenance demands. A fair system would distribute essential work transparently and provide genuine leisure, art, privacy, and personal projects. Dangerous duties could rotate or receive compensation. People unable to perform certain roles would contribute differently. A less fair system could assign occupations by family, genetics, test scores, or government decision. Children might inherit professions because the ship required predictable succession. Over time, technical guilds could become castes. The argument for assignment would always sound practical. Training is expensive. Rare expertise must be preserved. Families often pass knowledge naturally. The cost would be a society where birth determines duty inside a world already determined by birth. A rebellion might begin around something small. A group of young adults refuses mandatory engineering assignments. The government responds that the reactor team lacks successors. Protesters argue that decades of poor planning created the shortage. Work stoppages spread. Life support technicians remain at their posts because immediate failure would kill everyone, while refusing non-essential maintenance. The council declares an emergency and restricts gatherings. Each side believes it protects the future. The government sees a generation abandoning responsibility. The protesters see authority using survival to eliminate choice. Both possess evidence. Resolution would require trust accumulated long before the crisis. A society that shared burdens fairly might persuade volunteers. A society with entrenched privilege would find every technical warning interpreted as political manipulation. The crisis could end through compromise. Essential service becomes mandatory for a limited period, applied to citizens from every social class. Senior officials and their children receive no exemption. The government funds automation and improves working conditions while creating a clear end date. The protesters accept part of the arrangement because their objections changed policy. The reactor gains enough trainees. Nobody receives everything they wanted. This ordinary political settlement could save the ship more effectively than heroic leadership. A civilization surviving centuries would depend upon thousands of compromises that prevented conflict from becoming absolute. The mission would not remain united because disagreement disappeared. It would remain united because people believed disagreement could alter the system without destroying it. Violence aboard would be uniquely dangerous. A weapon damaging a wall, cooling pipe, or control system could affect people far from the conflict. Sabotage might destroy resources impossible to replace. Civil war inside a generation ship would resemble fighting within a submarine, city, and ecosystem simultaneously. Governments would restrict weapons and secure critical areas. Surveillance could identify threats early. These protections risk creating a permanent security state. A person expressing anger at the mission might be treated as a potential saboteur. Political dissent and technical danger could become difficult to separate. Authorities might arrest opponents before any crime occurred, claiming that the cost of waiting was too high. The ship's safety depends upon preventing catastrophic action. Its moral survival depends upon allowing people to condemn the mission openly. A civilization unable to distinguish speech from sabotage would preserve order by destroying legitimacy. A violent attack on life support would affect law for generations. Survivors might support extensive surveillance after witnessing how close the ship came to disaster. Children born later would inherit restrictions created by an event they knew only through recordings. The danger could remain real. The political response could also exceed it. Every security system creates power that later leaders may use for other purposes. The Constitution might require automatic review of emergency laws after a defined period. Citizens with direct memory of the attack would testify alongside people harmed by surveillance. Independent engineers would assess whether technical changes reduced the original vulnerability. The ship must be capable of learning from violence without allowing one violent person to govern the future indirectly through permanent fear. The option to divide the ship could reduce political pressure. Large generation vessels might consist of several habitats connected by transport structures. Communities could gain autonomy while sharing propulsion and external protection. If disagreement became irreconcilable, modules might separate after reaching a star system with sufficient resources. One group could settle a planet, another remain in orbit, and another continue toward a different star. Designing for future division would recognize that unity cannot be guaranteed. During interstellar cruise, physical separation may be impossible. Every habitat depends upon central engines or reactors. A faction attempting to leave could strand itself. The promise of later autonomy might not resolve present conflict. Still, the existence of a credible exit after arrival changes power. People cooperate more freely when membership is not eternal. The mission could aim to deliver a family of societies rather than one permanently unified civilization. The vessel might also carry smaller independent craft capable of supporting several hundred people for decades. These would function as lifeboats, construction vehicles, and limited forms of political exit. Launching one into interstellar space without a reachable destination would be dangerous. Near a star system, it could allow a community to settle a moon or asteroid separately. The craft would give physical meaning to the right of departure. Providing this option would consume resources and create security concerns. A group controlling an auxiliary vessel might threaten the main ship or take essential equipment. Governments could restrict access until the promised exit became largely theoretical. A right exists meaningfully only when institutions prevent those in power from blocking it whenever it becomes inconvenient. Psychological health would become political because confinement affects motivation, judgment, relationships, and trust. The population would need private spaces, varied environments, recreation, counseling, and meaningful work. A government could misuse mental health systems to classify dissent as illness. Someone rejecting the mission might be described as suffering destination alienation. Treatment could become another form of ideological correction. Clinicians would need strong independence and confidentiality. They should recognize that despair can arise from genuine injustice rather than individual disorder. Improving a person's mood without addressing the conditions causing distress would preserve the system at the expense of the patient. The mission's leaders might prefer psychological explanations for political problems because machines are easier to repair than legitimacy. A healthy society would accept that some emotional suffering contains information about the world producing it. The opposite danger would involve romanticizing every form of despair as political insight. Severe depression, paranoia, trauma, and other conditions would still require treatment. A person could be genuinely ill and politically critical at the same time. Clinicians would need to care for individuals without determining whether their beliefs were acceptable. Courts would need to distinguish impaired capacity from disagreement. Political leaders should have no authority to order treatment for ideology. These protections appear familiar on Earth and become harder aboard a ship where one person's actions could threaten everyone. The greater the technical danger, the stronger the temptation to merge medicine, security, and political control. The population would need to defend boundaries between these institutions even during crisis. Children would be especially vulnerable to inherited expectation. From birth, they might hear that humanity depends upon them. Their health, education, profession, relationships, and possible children would appear in long-term plans. This could produce pride. It could also make ordinary failure feel like betrayal of generations. A student struggling with mathematics might believe they had disappointed ancestors. A person discovering infertility could feel that their body had failed the mission. The ship would need a culture in which individual worth remained separate from demographic and professional contribution. People who had no children, performed no critical job, or questioned the voyage would still belong fully to the community. A civilization survives through specialists and parents. It remains humane through the refusal to measure every person only by usefulness. Adolescence could become the period when many citizens first rejected the mission. Children accept the world surrounding them. Teenagers recognize that its rules were created by other people and begin imagining alternatives. On Earth, this process can include travel, subcultures, new careers, migration, and separation from family. The ship would need to create internal forms of distance. Young adults could move between habitats, join temporary communities, change work, explore virtual environments, or participate in governance. Without these possibilities, rebellion could focus upon the vessel itself. The ship would become the parent nobody could leave. A society that feared adolescent opposition might increase control at precisely the age when people needed meaningful autonomy. Doing so could transform ordinary development into permanent political hostility. The founders could never guarantee this culture. They could design institutions, architecture, and educational principles. Descendants would reinterpret them. Ethical planning across centuries means accepting the loss of control. This may be the deepest challenge for the launch generation. They would need to construct a mission capable of continuing without requiring obedience to their intentions. They must trust future people to change the ship, laws, culture, and destination. A founder seeking certainty might encode rigid safeguards. The navigation system could refuse course changes. Artificial intelligence could block population policies outside original parameters. Sacred sections of the charter could be made technically difficult to alter. Each safeguard protects the mission against one form of failure and creates another form of domination. The descendants become prisoners of a plan precisely because the founders feared their freedom. An ethical ship may need a constitutional right to end the mission. Citizens could choose to stop at another star, remain permanently aboard, divide the population, or abandon the original destination. This right would be limited by physics. A vote cannot produce fuel or a habitable planet. The ship could still preserve several realistic options through design and continuous observation. The right to abandon the mission would change its cultural meaning. Continuation would become an action renewed by the living rather than obedience inherited from the dead. Each generation could say that it remained aboard one chosen path because available alternatives were worse or because the destination still mattered. The mission becomes morally stronger when people possess the authority to end it. It becomes operationally less predictable. Ending the mission would not necessarily mean stopping the ship immediately. The population could redefine success. It might decide that reaching any star system with accessible resources satisfied the original ambition. It could transform the vessel into a permanent interstellar habitat. It could launch probes while abandoning human settlement. The word failure would become politically important. Leaders devoted to the original destination might describe every alternative as failure. Reformers could describe adaptation as survival. A mission lasting centuries must allow the meaning of success to change when knowledge and people change. Otherwise, the founders' vocabulary becomes another form of control. The descendants should be able to say that the original plan no longer serves them without saying that every life and sacrifice before them was meaningless. Suppose the 12th generation holds such a vote. The ship is halfway to its destination after 3 centuries. New observations show that the target planet may possess a toxic atmosphere. Another star lies within reach, though changing course would add 200 years. One faction supports the original route, arguing that orbital habitats can be built even if the surface is hostile. Another proposes the new star. A third wants to slow near an unplanned system and construct a permanent space-based civilization. Every option imposes consequences upon people not yet born. Continuing respects earlier sacrifices and risks an unsuitable world. Turning extends confinement. Stopping abandons the destination while offering earlier access to resources. The generation voting cannot escape the act of choosing for descendants. Giving future people autonomy does not remove transgenerational power. It transfers that power from dead founders to living citizens. The vote could split almost evenly. A simple majority would allow half the population to determine centuries of future movement. Requiring an overwhelming majority could make change impossible. The Constitution might require agreement from several institutions, habitats, and age groups. Engineers would certify physical feasibility. Citizens would decide among feasible options. A future generations council would assess preserved choices. These procedures would slow action and reduce the chance that one temporary passion redirected the vessel. They could also favor the current route because doing nothing required less formal agreement. Every decision rule contains a bias. The society would need to make that bias visible rather than presenting procedure as neutral. Every society makes decisions affecting future generations. It builds infrastructure, accumulates debt, changes climate, preserves knowledge, and wages wars whose consequences outlive the decision makers. The generation ship concentrates this responsibility into a visible chain. Citizens can see the water reserves their descendants will use. They can calculate how current births affect the workforce 50 years later. They can measure structural fatigue accumulating toward another century. This visibility might produce stronger long-term ethics. Political debate would include people who do not yet exist because every major choice shapes the closed world they will inherit. Institutions could appoint guardians for future generations or require long-term impact reviews. Such guardians would still be living people interpreting interests that future citizens cannot express. They could become conservative authorities opposing change in the name of the unborn. Protecting the future can justify preserving current power. The future generations themselves would never form one interest. Some would value arrival, others freedom, stability, innovation, family, faith, or exploration. A policy benefiting one possible future may prevent another. The founders cannot ask what descendants want because those wants will develop inside the world the founders create. Building a highly disciplined ship may produce citizens who value discipline. Building a pluralistic society may produce citizens who demand more choice. Institutions shape the preferences later used to judge them. Consent across generations can therefore never become complete. The best available alternative is to preserve capacities, education, health, information, political participation, material options, and the ability to revise inherited rules. The founders should give descendants the tools to choose rather than attempting to predict every choice. Material reserves are part of those tools. Extra fuel provides navigational freedom. Redundant habitats provide space for different communities. Genetic archives provide reproductive options. Manufacturing capacity allows redesign. Educational breadth prevents the mission from narrowing every mind toward maintenance. Redundancy appears inefficient at launch. Every unused room and spare machine increases mass. A project struggling to reach another star may remove them to improve speed. This optimization can create a vessel with no moral margin. Every person must perform expected work. Every habitat must remain occupied. Every resource follows one purpose. The descendants inherit a system whose efficiency leaves no room for alternative lives. A humane generation ship would be deliberately inefficient in ways that support freedom and recovery. It would carry more possibility than the minimum required for survival. Time could erode these margins. A crisis might consume spare fuel. Population growth could fill unused habitats. Manufacturing failures could reduce reserves. Each generation would decide whether to preserve options for later people or use them to solve present problems. A community suffering cold during a power shortage may dismantle an unused engine component for material. The component had supported a hypothetical future course change. The immediate need is real. The future choice is uncertain. After many such decisions, descendants could discover that the ship's theoretical freedom had disappeared gradually. No tyrant removed it. Generations used it piece by piece to survive. The moral history of the voyage would be written through resources spent by people facing conditions the founders could not imagine. Earth might develop faster propulsion after launch. A later ship could overtake the generation vessel and reach the destination first. The original mission would receive messages describing cities built by travelers who departed centuries later. This could destroy its central purpose. Generations had accepted sacrifice to become the first humans around another star. The destination would already contain a society with newer technology and direct cultural ties to a future Earth. The faster civilization might offer rescue or transport. Some inhabitants would leave. Others would refuse to abandon a ship that had become home. The population could divide between those seeking reintegration and those defending shipborne independence. The mission would confront the possibility that its suffering had become technologically unnecessary. Continuing would preserve culture and abandon the original justification. Stopping would admit that centuries of work ended through progress elsewhere. The overtaking ship could appear in the distance as a light moving far faster than anything the old vessel could achieve. Its passengers might experience a journey of only several decades. Their language, medicine, computers, and political culture would come from an Earth hundreds of years more advanced. To them, the generation ship could seem primitive, authoritarian, fragile, or historically priceless. To its inhabitants, the newcomers might seem careless, culturally alien, and unable to understand the society created by slow travel. Rescue would not be simple. Moving thousands of people between vessels requires matching velocity, space, life support, and political agreement. The faster ship may have capacity for only a small number. Selection would reopen old inequalities. Who leaves? Children, specialists, leaders, the sick, or people chosen by lottery. Accepting rescue could divide families and remove the people most able to maintain the old ship. No calculation before launch could guarantee that this would not happen. Waiting for better technology may be rational, though each future generation could wait again. The decision to begin an interstellar mission always risks becoming obsolete. The founders would need honesty about this possibility. Presenting the voyage as the only path to the stars would create betrayal when alternatives emerged. Presenting it as one experiment among many would reduce heroic certainty and support later adaptation. A society built around being humanity's sole hope becomes fragile when evidence challenges that status. A society built around the value of its own lives can survive changes in external meaning. The ship must be worth inhabiting even if nobody needs it to complete the mission. Arrival itself could threaten unity more than the voyage. The population would have spent centuries organized around movement and close survival. A planet introduces territory, resources, weather, biological risk, and the possibility of physical separation. Some people would want immediate settlement. Others would fear gravity, microbes, and open landscapes. Technical teams might recommend decades of orbital study. Younger citizens could accuse elders of postponing the future they were promised. The ship's professions would lose or change status. Navigation and closed system engineering might become less central. Planetary ecologists, builders, and agricultural specialists would gain authority. Families rooted in ship institutions could resist the redistribution. A successful voyage could end the social structure that made success possible. Property would become a major source of conflict. The planet could contain land and resources far beyond anything available aboard. Who would control them? Families might claim settlement rights based upon work performed during the voyage. Habitats could demand territories proportional to population. The central government might declare the planet a shared inheritance. Individuals could argue for freedom to establish independent communities. The first landing sites would possess strategic importance. Water, safe terrain, minerals, and transportation routes could create inequalities lasting centuries. Decisions made during arrival might reproduce the closed ship's class system across an entire planet. The society would need laws governing a world no citizen had yet inhabited. Drafting them aboard would repeat the founders' original mistake if future settlers lacked power to revise them. The planet might contain native life. Protecting it could require remaining in orbit or restricting settlement. Descendants would discover that the destination chosen as their inheritance already belonged to another biosphere. Some would argue that centuries of sacrifice gave humanity a right to use the world. Others would answer that distance and suffering create no ownership over independent life. The founders selected coordinates without receiving permission from anything living there. The mission's purpose would split between preserving humanity and respecting life beyond humanity. Both values could be traced to the launch charter. Neither offers a simple solution. The population might establish habitats on moons and asteroids, reaching the star without occupying the planet. The voyage would succeed scientifically and fail according to the images that inspired it. A native civilization would create an even greater crisis. The planet may have appeared empty at launch because its inhabitants had not yet developed detectable technology or because their signals were misunderstood. By arrival, the civilization could be visible. The generation ship would approach as an immense foreign vessel containing thousands of people who believed the system was their destination. The local society might refuse entry. Humanity would have no moral right to settle by force simply because ancestors crossed centuries to arrive. The ship could remain in distant orbit, negotiate, continue to another star, or establish habitats in unused regions of the system. The mission's darkest inheritance would then become external. The founders had not only chosen for descendants, they had chosen a destination affecting beings they never knew existed. A generation ship must therefore prepare descendants for disappointment. The destination may be hostile, inhabited, politically inaccessible, or already settled by later missions. The vessel must remain a viable home under every outcome. This preparation would alter public imagination. Children should learn that arrival is an investigation rather than a promise. The planet is a candidate, not a reward. The mission exists to expand human possibility, not to guarantee a landscape. Hope built upon uncertainty can survive evidence. Hope built upon certainty becomes anger when reality arrives. The founders may fear that cautious language weakens motivation. The opposite could be true across centuries. Honest uncertainty gives descendants permission to adapt without interpreting change as failure. The ship's society would never remain perfectly stable, and it should not attempt to. Stability across centuries means the capacity to change without collapse. Governments can be replaced, cultures transformed, and destinations revised while life support and civil rights continue. A rigid society may preserve order for several generations and fail catastrophically when conditions exceed its rules. A flexible society experiences conflict more often and develops ways to resolve it. The mission would need legitimate procedures for disagreement, elections, courts, assemblies, local autonomy, transparent science, and constitutional revision. These systems consume time and create uncertainty. They also allow conflict to occur without damaging the hull. Political inefficiency can be a form of structural protection. The ship would also need rituals of peaceful defeat. Political groups must accept losing votes without believing the result ends their identity or future. Leaders must surrender office. Experts must tolerate decisions that select one reasonable risk over another. In a closed society, losing can feel permanent because opponents remain nearby and the consequences affect everyone. A faction defeated over course selection may believe its descendants have been condemned by the majority. Institutional protections, future review dates, and local autonomy could make defeat survivable. A decision might be reconsidered when new evidence arrives. Minority communities could continue preserving their knowledge and values. Unity would depend less upon agreement than upon confidence that no political loss erased a group from the future. Trust would become a resource as essential as water. Citizens cannot personally inspect every reactor, medical model, demographic forecast, or navigation calculation. They must rely upon experts and institutions. Trust grows through transparency, shared burden, accountability, and the willingness to admit uncertainty. It collapses when leaders hide shortages, exaggerate danger, or protect privileged groups. A ship can recover from a mechanical failure if people believe the repair plan. The same failure can become political catastrophe when every announcement is suspected of manipulation. Citizens may refuse rationing, hide resources, or sabotage systems they believe serve an elite. The vessel would carry tons of spare material. It could not store replacement trust inside a warehouse. Trust would need maintenance before crisis, just like machinery. Public institutions would publish ordinary data, admit minor errors, and allow independent inspection. Leaders would experience the same restrictions imposed upon citizens. During stable periods, these practices might appear slow and unnecessary. Their value would emerge during emergency, when people accepted sacrifice because earlier behavior had established credibility. A government cannot build trust instantly after announcing catastrophe. If it spent decades manipulating information, accurate warnings would sound like another attempt at control. The ship's social systems would need preventative maintenance as deliberate as the inspection of pressure seals. The founders might test the society before launch through long-duration habitat experiments. Volunteers could live in closed environments for years, studying conflict, resource management, and psychological health. No experiment can reproduce birth, aging, cultural drift, and inherited authority across centuries. The first true test would be the mission itself. Descendants would become participants in an experiment they never volunteered to join. Ethical review would end at launch while the consequences continued. The ship could create institutions for ongoing consent, research oversight, and public revision. Every generation would evaluate medical, demographic, and social policies as if redesigning the experiment around living participants. This would acknowledge a difficult truth. The mission cannot be ethically approved once for all time. Its legitimacy must be renewed by those experiencing it. Researchers aboard would study the population continuously. They would monitor health, fertility, psychology, culture, education, and social networks to detect risks before they became irreversible. Research could improve life and transform everyone into a permanent subject. Data about relationships, beliefs, reproduction, and mental health would be valuable to mission planning. Privacy could interfere with scientific accuracy. Citizens should be able to refuse studies. A small population makes refusal statistically important and politically visible. Authorities might argue that complete data is essential to survival. The ship would need strict boundaries around consent, anonymization, access, and the use of personal information. Preserving society cannot justify treating every private life as public material. The darkest version of the ship would hide behind success. Its population remains healthy, machinery operates, birth rates follow targets, no rebellion threatens navigation. The destination approaches exactly as planned. The society appears stable because dissent has been educated away, reproduction is controlled, professions are assigned, history is curated, and artificial intelligence identifies disruptive behavior early. Citizens experience comfort and security. They possess limited authority over the structure producing both. Such a ship could reach another star efficiently. Its descendants would survive through the sacrifice of political freedom and cultural unpredictability. The mission would preserve humanity biologically while delivering a society shaped around obedience. Technical success could therefore conceal moral failure. The people aboard might not experience themselves as oppressed. They could value order, duty, and collective survival. Their culture would have developed inside the system from birth. This does not make the problem disappear. Preferences can be shaped by restricted education, controlled information, and the absence of alternatives. A person may sincerely support a structure that prevents them from imagining another life. Outside observers from Earth could condemn the society while misunderstanding the dangers it faced. Shipborne citizens could reject terrestrial ideas of freedom as irresponsible luxuries. The moral judgment would remain difficult because both cultures arose from different material realities. The clearest question would concern whether people could access information, organize opposition, revise institutions, and make choices whose outcomes were not predetermined. The opposite ship could fail through freedom. Citizens possess broad rights, refuse coercive reproduction, choose professions, revise laws, and eventually vote to abandon the destination. Population declines or essential skills disappear. The vessel becomes less capable and may never reach another star. This outcome would preserve autonomy and lose the mission. It could also lead to extinction, removing freedom along with life. The choice between authoritarian survival and voluntary failure is too simple, though every generation ship would move somewhere between these risks. Institutions must coordinate without dominating, persuade without manipulating, and protect future people without consuming present lives. No engine design can solve that balance. It would depend upon political culture renewed across generations. Freedom does not require the absence of obligation. Citizens on the ship could accept duties created through fair procedures, limited duration, shared burden, and protection of fundamental rights. A person may be required to contribute emergency labor without having a profession assigned for life. Birth incentives may exist without compulsory pregnancy. Technical areas may be secured without monitoring every private conversation. The difference lies in whether collective needs become excuses for unlimited authority. A democratic society can impose serious obligations while allowing citizens to challenge their scope, evidence, and distribution. The generation ship would need a political culture mature enough to live with this complexity for centuries. Perhaps the mission should begin only when the ship can support a population so large and a habitat so rich that descendants experience genuine social freedom. Tens of thousands or more could create varied communities, professions, relationships, and political alternatives. Such a vessel would be immense. Accelerating it toward another star could require energy and infrastructure beyond anything humanity possesses. Waiting for that capability might postpone interstellar settlement for centuries. Launching a smaller ship sooner could appear courageous. It would place stronger constraints upon people unable to approve the risk. The true technological threshold for a generation ship may be ethical scale rather than basic survival. Humanity is ready when it can carry a world spacious enough that children do not feel built for the mission. The size of the habitat would influence freedom psychologically as well as politically. A vessel containing only corridors, work areas, and compact rooms would remind people constantly that their world existed for transportation. Large gardens, varied architecture, private spaces, water, art, sports, and districts designed without immediate technical purpose would allow life to exceed the mission. People could wander without performing a task. This apparently wasted space would support mental health and cultural development. A park produces no propulsion. It may preserve the motivation of thousands of people responsible for propulsion. The ship's builders would need to understand that beauty, play, and unstructured time are parts of life support when the voyage lasts longer than any passenger's life. A generation ship could also carry only adults in suspended animation, avoiding births during transit. This would remove most transgenerational consent problems and place extreme dependence upon preservation technology. If the system failed and children became necessary, the original ethical problem would return under emergency conditions. A vessel expected to sleep through the journey may lack schools, cultural institutions, and a society designed for multiple generations. Radical life extension could allow founders to reach the destination themselves. Their long lives would maintain responsibility and reduce cultural drift. It could also produce a society dominated by people who selected the mission and never surrendered power. Every biological solution changes the political problem without removing it. Embryo ships would create another variation. A robotic vessel could carry genetic material rather than a living population. Artificial wombs and machines would create and raise children near the destination. No generation would be confined during the journey. The first children would be born inside a society without adult human founders. Their caregivers would be machines carrying values and instructions created on Earth. The children would still lack consent and inherit an even more complete dependence upon the mission design. They could not ask living parents why the voyage began. Their culture would be shaped deliberately by software. Avoiding one generation's confinement could create a population whose entire childhood became an experiment in artificial upbringing. The safest solution may be speed. A ship reaching another star within 20 or 40 years would involve children and perhaps one generational transition, rather than centuries of inherited confinement. Faster travel reduces the number of people born into the mission. Speed demands enormous energy and creates severe collision hazards. A large vessel traveling at a substantial fraction of light speed carries destructive kinetic energy. Shielding becomes harder. Deceleration requires another immense system. The ethical pressure of slow travel becomes the physical pressure of fast travel. Humanity can reduce generations by increasing engineering risk. The ideal interstellar mission would be short enough that its passengers largely consented and slow enough that its machinery could survive. Whether such a region exists for a large human vessel remains unknown. Another solution would be delaying human departure until robotic missions had built settlements around the destination. Fast probes could survey planets, construct habitats, gather resources, and create propulsion infrastructure. The human vessel would then travel toward a known and prepared environment. It could be smaller, faster, and less dependent upon uncertain arrival conditions. The voyage might still last decades or centuries. Waiting would reduce risk and remove the heroic image of humanity entering the unknown first. Machines would perform much of the exploration. Humans would follow after a route and refuge existed. The darker moral problem becomes easier when descendants inherit fewer uncertainties. Patience could be one of the most important interstellar technologies. Imagine the final referendum before arrival. The ship has traveled for 400 years. The planet appears suitable for settlement, though its atmosphere contains unfamiliar biology. Orbital habitats are possible. The population has divided almost evenly. The oldest political tradition says that landing completes the promise made at departure. A newer movement argues that the shipborne civilization should remain in space and protect the planet. A third proposes limited settlements under strict quarantine. The founders cannot answer. Their recordings explain hopes formed before anyone knew the planet's reality. The living citizens must choose, knowing their decision will shape children born after arrival. At this moment, the mission finally belongs entirely to its descendants. Their ability to decide freely would be the strongest evidence that the voyage succeeded. The ship preserved life, knowledge, options, and institutions capable of facing reality without obedience to a dead plan. They might choose a future the founders would celebrate. They might choose one the founders would consider betrayal. The moral value lies partly in their authority to choose it. A generation ship should deliver people to another star rather than deliver an ancient command through people. The darkest problem with sending humans to another star is that the mission must use generations as a bridge. The founders begin a journey knowing that others will perform most of the labor, endure most of the confinement, and face the destination. Those future people cannot consent at launch. They can only inherit enough freedom to decide what the inheritance becomes. The ship must provide life without claiming ownership over the lives it creates. Population models, genetic archives, closed ecosystems, artificial gravity, industrial renewal, and powerful engines may make the crossing physically possible. None can guarantee that descendants will share the original purpose. The mission can force continuity and risk becoming a prison. It can protect freedom and accept that freedom may redirect or end the voyage. Centuries after departure, a child might stand in an observation hall while the destination star brightened ahead. She would know the names of founders, the history of revolutions, the repairs hidden inside the walls, and the generations buried within the ship's ecological cycle. She would owe her existence to the mission. She would owe it no automatic obedience. The society around her would be united if unity meant shared care for one another and the world keeping them alive. It would be divided if unity meant agreement about every purpose inherited from Earth. She might vote to continue. She might vote to turn. She might choose a future nobody imagined at launch. The fate of the mission would depend upon that choice being real. A spacecraft can be programmed to reach a star. A society cannot be programmed across centuries without reducing its people to instruments. It must be educated, trusted, challenged, repaired, and allowed to change. The vessel will age. Its population will change. Its culture will drift. Its destination may disappoint. Its original purpose will lose emotional force. These processes are not deviations from the mission. They are the mission as lived by human beings. The generation ship most likely to remain united would not demand one unchanging belief. It would unite people around the protection of life, knowledge, dignity, and future choice. The destination would remain important without becoming more valuable than the people traveling toward it. Humanity could reach another star through such a society. It may arrive on a different planet, remain inside the ship, or become something the founders would barely recognize. The darkest problem has no final engineering solution. To reach the stars, the founders must build a world they are willing to lose control of.